Good evening, all, and welcome to IGTA International 7-in-1 Oil and Gas Professional Development Short Course Training, which is starting right away. My name is Zainab Oiza Yusuf, a coordinator with IGTA. I want you all to know that at IGTA, we have the best industry experts globally that will be leading these trainings. I will be presenting the lead trainer, Dr. Nabil Sami, right away. At Inside Global Training Academy, IGTA, we are committed to delivering world-class training for oil and gas professionals. Our class tonight will be led by Dr. Nabil Sami, a distinguished petroleum engineer and business development manager at Nile Oil Service Petroleum Company. Dr. Nabil is a petroleum engineer. He has a BSc in petroleum engineering from that's the Future University in Egypt in affiliation with Missouri University of Science and Technology. Secondly, he also went to American Diploma School. That's American Diploma from Genius American School. Business Development Manager at Nile Oil Service Petroleum Company. He is a drilling engineer at Calder Petroleum Company for about 3 years now. He is also a business marketing merchant at Noon Merchants. He is also a simple business marketing He's a simple business marketing engineer at S&T Company. He's a graphic designer and advertiser at training companies and academies. He also is a writer of books in English on petroleum, author of a small book about deep wells, a journey into petroleum. He is an author of a book about petrophysics principles. He also is an author of a book on oil and gas production system designs and operation. He is, however, a member of Egyptian syndicates and a member of the General Syndicate of Press and Media. He is a certified international and national petroleum trainer. He also is a general manager and professor at Petroleum Oil Service Libya Company, SEBA. He is a freelancer professor at STC Oil and Gas Service Company. He is a technical advisor and professor at International Petroleum and Mining Academy, Cameroon. He is a freelancer professor at Adaptive Geoenergy, Iraq. Also, he is a freelancer professor at Advantage Learning, India. He is a technical advisor and professor at Educave Training Academy, India. Professor Samuel is a technical advisor and professor at Educave Training Academy. He is a manager and professor at Yaoundé Center, Cameroon. He is a freelancer professor at Akidu Training Emirates Company and Horizon Oil Well Academy. He, however, is a freelancer professor at Ellis Training Center, Libya. Among others include Petroleum Training Oil Services, Libya, Petronovo Petroleum Integrated Service Company. He is also, apart from the fact that he's a freelancer professor, he is a training coordinator at AM Petroleum Service Company. And Also at AAPG, SPE, SCG, IIPE, URI, American Association of Petroleum Geologists. He is a member of the Society of Petroleum Engineer, Society of Economics Geologists, India Institute of Petroleum and Energy, SPE. He is an undergraduate researcher initiator. He is also a freelancer professor at Petro Oil Company. He is a freelancer professor at International Training College. He is a freelancer professor at Yemen Petroleum and Mineral Training Center. He has written many books. He's a writer of articles in English on petroleum at Petrocraft magazine, Petro Today magazine. He also writes articles in Arabic on petroleum. He is a head and professor at Petro Skill Academy. He is a freelancer professor at C Petro Company, at Oil Company for Training and Consulting, at Online Petroleum Academy, OPA Energy. He is a freelancer professor at Oil Stream Service Company for Training Consultant, Iraq Company. He is a head and professor at CAN for Training and Consulting Company. However, he also heads and trains. He also heads and happens to be a trainer professor at Petroleum Elite for Training and Consulting Company. He's a freelancer professor at Boost Up for Petroleum Academy, among many others, like International Association of Drilling Contractors for SEWS University, ZAD Academy for Training Consultant Agreement and Joint Cooperation with Training Centers in Arab countries. He's a freelancer professor at National Academy for Training Consultant and Technology, Amman, Jordan. He's a freelancer professor at Petro Master Academy, JESCO Petrom Training Consulting Center, Future Training Academy, Resala Training Center. He is a freelancer professor at Creativity for Change, Algeria. He is a freelancer professor at University of Jonda in Ethiopia. He is a freelancer professor at Forward Academy. He's also a freelancer professor at Mediterranean Queen for Training and Consulting, Libya. He's a freelancer professor at AIIL for Training and Consulting, Libya, Tripoli Company. Also at Millennium Training and Consulting Services, Libya Company, at Horus Training Center. He's a freelancer professor at Top Leaders for Training and Consulting, Sudan and Egypt Center. He's a freelancer professor at Egyptian Life Support for Training Center. He's a freelancer professor at United Academy, Turkey, Istanbul. He is a freelancer professor at Progress Academy. He's a freelancer professor at Egyptian Academy. He's a technical advisor and professor at Petroleum and Maritime for Training and Consulting, Nigerian Center. He heads and happens to be a professor at Energy Solutions for Training and Consulting, Nigerian Academy. He's a freelancer professor at Crayon Training Academy. He also is a freelancer professor at Petrocas for Training Consultant, United Arab Emirates Company. He's a freelancer professor.
Yeah, thank you so much, Ms. Zainab. You have done an amazing job. I think that if we have to really go through a little brief of the summary of the pedigree of the lead trainer, it will really take us a long period of time. However, for those who want to know, we can get those informations, the summary of it available to you, because Dr. Nabil is actually a seasoned professional with very vast background, and you can imagine how difficult it can be to actually summarize or make available. the key informations about such an individual. However, this is to summarize it all, that the person that will be speaking to you all today, that will be taking you guys throughout this training program that will last within this week, for week 1 and week 2 next week, and then heading up to week 3, week 4, week 5, week 6, and week 7 and week 8, based on the complexity of the natures of the training. So I will be handing over right away to Dr. Nabil at this point in time, so that we don't have to, this is strictly a training program, so that we don't have to spend a lot of time going through the vast nature of his brief citation. That is actually his brief citation, and he has over a lot of PhDs. We can't be mentioning all of that, but it's really, you are going to be listening to one of the most sound professionals in the training industry. So please feel free, while the training is going on, drop your questions in the chat box, and by the end of the training, their questions will be taken. After today's class, the next class will be coming up again on Sunday from same time, 7 p.m. So Dr. Nabil, confirm you can hear me, as I will be handing over to you right away, so that we can commence with the training.
Yes. Yes, I can hear you.
Okay, so I'll stop sharing now. You can share from your end.
Okay. Today's session we will talk about directional drilling. So let's get started. As an introduction to directional drilling is the science of deviating a well bore along a plane course to a subsurface target whose location is a given lateral distance and direction from the vertical. Also for directional drilling, which is a technique used in the oil and gas industry to drill wells at non-vertical angle. This method allows operators to reach target reservoirs that are not directly beneath the drilling rig to optimize resource extraction while minimizing environmental impact. And from the advantages of directional drilling, which is access reservoirs under obstacles or maximize reservoir contact for increased production to reduce surface footprint and making it more environmentally friendly, enhances recovery rates from unconventional reservoir. What are directional wells? Directional wells are deviated from vertical, which is straight line. Direction wells are drilled with an intentional control to hit a predetermined target. For inclination and azimuth, inclination, which is angle, and azimuth, which is direction. So we must to think about 3D, which is when we're using directional drilling. Also for the key component of directional drilling, which is mud motor, which is used to rotate the drill bit without rotating drill string. Rotary steerable system, which is RSS, allow continuous drill string. Measurement while drilling or logging while drilling to provide real-time data on well trajectory. Also other components of directional drilling, which is MWD, measurement while drilling, logging while drilling to provide real-time data on well trajectory. and formation properties. Surveying tool, which is inclination and azimuth sensors, ensure accuracy in drilling direction. Okay. For types of directional drilling, or actually directional wells, we have the vertical type, which is straight well having a bore within planned deviation of vertical. And for the G type, which is have a bore within a straight section, tangent section, drop section, build section, this type of well drill to improve efficiency of well and also to assist in location of blowout. Blowout, which is uncontrolled release of crude oil or natural gas, which is a dangerous problem, can cause loss of life or loss of the rig, and also loss of the workers who is working on the rig. So to prevent blowout, we have to use a blowout preventer, which is used to seal or monitor the crude oil or natural gas to prevent blowout. Also for the S type, which is the same as J type, which is have a bore within straight section, build section, tangent section, which is straight to the target, to locate the surface location directly above the target. For the S type, sorry, actually for horizontal type, which is having a bore within a straight section, build section, tangent section, the well is drilled to a point above a reservoir, then it deflected and an angle increases until it reaches 90 degrees or more. So one horizontal borehole can produce reservoir better than several vertical wells. Also for horizontal drilling, which is the well bore is turned almost 90 degrees to maximize contact within the reservoir. Okay. For inaccessible location, which is directional drilling, is an essential technique for reaching oil and gas reservoirs that are located in areas where conventional vertical drilling is impractical or impossible. So also in inaccessible locations include offshore and subsea fields or urban and environmentally sensitive areas, beneath obstacles like lakes, rivers, mountains, and others, remote or hostile environment, relief wells for well control and blowout prevention, technological used for inaccessible location, which is RSS, which is rotary steerable assist system, which is provide control of well trajectory, and mud motor, which is enable drilling without rotating the entire drill string, extended reach drilling, which is ERD, allows the drilling wells several kilometers away from the rig. Also, we have the geosteering and logging while drilling versus the measuring while drilling, which is real-time formation evaluation and trajectory control. Multilateral drilling, which is one well bore branches into multiple targets. Also for the salt dome, which is our massive underground salt formations that can create traps for oil and gas. These structures are often surrounded by hydrocarbon, making them attractive drilling target. Drilling near or through a salt dome presents unique challenges that require advanced directional drilling technique. And also from the challenges of actually drilling near salt dome, unstable borehole condition, seismic uncertainty, the differential sticking, abrasion, and tool wear. Also for salt dome drilling, which is a trap created by intrusions of stratified rock layers by ductile non-porous salt, and for the inaccessible location, which is difficult or impossible to reach. For the fault controlling, which is a set of recent techniques that were developed to increase plant availability and also to reduce the risk of safety hazards. Also for the fault controlling, which plays a critical role in trapping hydrocarbon by creating structural traps or acting as a migration barrier. Drilling in faulted reservoir presents unique challenges that require precise directional drilling technique. And also for the challenges in faulted reservoir, which is like wellbore instability, pressure variation, seismic imaging uncertainty, drilling through faults or reservoir compartmental, which is some faults seal hydrocarbon while others allow leakage. Okay. So for the kickoff point, we'll start with actually for the kickoff point, which is the depth at which the well starts deviating from vertical, determined based on reservoir depth, formation properties, and drilling objectives. For the build-up rate, which is actually the rate at which the wellbore inclination increases, measured in degree per 100 feet. And for the azimuthal direction, which is compass direction of the wellbore measured in degree from north. And also for the inclination angle, which is actually the angle between the wellbore and the vertical. Actually, for the true vertical depth, which is the vertical distance from the surface to a point in the wellbore measured in a straight line. And for measured depth, which is the actual length of the wellbore by using, or actually along its trajectory, including curves and horizontal section. For the horizontal displacement, which is the horizontal distance between the wellhead and a point in the wellbore. And also which is the distance projectile has moved between its point to release and its point of landing, which is measured as a straight line parallel to the ground. Actually, as another definition for the horizontal displacement. For sliding and rotating in directional drilling, sliding, which is when the drill string remains stationary, while the mud motor rotates the drill bit. And actually for the rotating, which is the entire drill string rotates, including the bit. And from the advantages of the rotating, which is higher rate of penetration than sliding, less differential sticking risk due to the continuous movement, better hole cleaning, and less torque and drag. For the downhole motor, in directional drilling, which is known as mud motor or positive displacement motor, which is a critical tool in directional drilling. It enables steering the well bore by rotating the drill bit without rotating the entire drill string. And also for bend sub, which is a short angle drill string component placed between the downhole motor and the drill bit. It provides a necessary deviation to steer the well bore in the desired direction during slide drilling. There is two types of it, which is fixed, non-moving, and adjustable, which is movable. For the surveying tool, which is used in directional drilling to measure the well bore trajectory and ensuring it follows the planned path. Also, we have the media of transmission. Others, this shows the non-magnetic drill collar, orienting key, orienting sleeve, scribe line tool face, bend sub, Allen screws bit, and this is called the downhole motor. Okay. For the horizontal drilling, which is an advanced form of directional drilling where the well bore drilled at a 90-degree inclination to maximize reservoir contact. It is used in oil and gas production, geothermal energy, and environmental drilling. And from the advantages of the horizontal drilling, and also we'll talk about the challenges. For the advantages of horizontal drilling, which is higher production rate, which is greater reservoir exposure, increases oil and gas recovery, fewer surface locations, which is reduces environmental impact and land use, better reservoir drainage, which is reduces the water and gas coning, enhanced recovery method, which is compatible with an hydraulic fracturing for shale formation. And for the challenges and limitations, which is high drilling cost, hole cleaning issues, which is cutting stems to accumulate in horizontal section, torque and drag problems, which is increased friction in long reach wells, casing and completion complexity, which is running linears, and production tubing can be difficult. So those are the challenges. Horizontal drilling. Also for the types of horizontal drilling or actually horizontal wells, we have the long radius, which is actually from 2 degree to 8 degree of 100. Medium radius, which is from 8 degree to 30 degree of 100, and the short radius, which is actually from the 30 degree to 60 degree of 100. Ultra short, which is from 60 degree to 200 degree of 100. For the applications of gas and water cooling, gas and water cooling, which is longer horizontal drain hole, increases the exposure of the pay zone, allows a higher production rate at lower drawdown pressure, resulting in less cooling. Also for the gas and water cooling are unwanted phenomena that occur during oil production when gas or water moves into the well bore due to the pressure imbalance. They reduce oil recovery and also can lead to production inefficiency. For the causes of coating, there is high production rate, reservoir heterogeneity, which is uneven permeability and pressure distribution, accelerate coating. Well placement, which is a well positioned too close to the gas cap or water zone, which is more prone to coating. Oil viscosity and mobility ratio. If gas or water has higher mobility than oil, coating happens faster. For the gas coating occur when the well bore is close to gas cap, gas moves downward into the oil column. And for the prevention methods, for the problems, which is increased gas oil ratio, reduces oil production efficiency, which is JOR, Premature gas breakthrough, which is limits oil recovery and can cause gas flaring. So those are the problems would happen. So for the prevention methods of them, lower production rate to maintain a stable oil column, horizontal wells to produce oil laterally, minimizing gas breakthrough, and downhole flow control devices, which is restrict gas flow into the well. For the water coning, which is occur when the well bore is near an aquifer or water contact zone, water which is pulled into the oil producing zone, and for the problems could happen like increasing water cut, which is reduces oil recovery efficiency, and water breakthrough, which is requires costly water separation and disposal. For the prevention methods, controlled production rates, which is avoid excessive pressure drawdown, perforation strategy, which is avoids perforating too close to the water zone, downhole water shutoff technique, which is also used by using bakers or gel treatment. And also for the solutions and mitigation techniques to optimize well placement, to use horizontal wells to increase oil contact and delay coning, reservoir pressure management, which is controlled depletion to prevent coning, intelligent completion technology, which is inflow control valves that regulate fluid entry. So those are the solution actually and the mitigations of techniques for the gas and water coning. Also, for the other major applications of horizontal drilling, we have to the maximum reservoir exposure, naturally fractured tight reservoir, thin dry reservoir, and less wells needed to develop a field. Okay. For stacked lateral, which is to locate on surface of ground the point at which well to be drilled. Also for stacked lateral drilling, which is an advanced well architecture where multiple horizontal laterals are drilled at a different depths within the same vertical or deviated well bore, using unconventional reservoir, child plays, and layered formation to maximize production from the multiple zone. Also for hole and casing sizes are the same as a single lateral. And for the multiple branch multilateral wells within two or more laterals drilled. Also, multilateral wells are advanced well designs where a single well bore has a multiple branch extending from the main bore. This technique maximizes reservoir contact, improve production rate, and reduce drilling and infrastructure cost. Also, this shows the TD, which is total depth, X, which is in north in feet, and east, which is in Y, actually also in feet, and true vertical depth also has a unit of feet. For the survey in directional drilling, which is to the process of measuring and tracking the wellbore trajectory to ensure it follows the planned path, which is essential for collisions avoidance, precise well placement, and maximizing reservoir contact. This shows the kickoff point, build section, end of build up or end of curve, tangent or hole, drop section, departure versus the true vertical depths in feet. For survey instruments, which is used to measure the azimuth and inclination of the well, for magnetic survey, which is uses the Earth's magnetic field to determine the azimuth of the well bore, the magnetic North Pole is not the same as the geographical North Pole. There is a difference. And also for magnetic survey and directional drilling is the purpose of using magnetometer to measure the Earth's magnetic field for determining the wellbore azimuth. It is used in measurement while drilling and gyroscoping tool to ensure accurate wellbore placement. And from the types of magnetic surveying tool, we have the measurement while drilling, gyroscoping survey, and magnetic single shot and multi-shot. Declination is the difference between the magnetic North Pole and geographical North Pole. East declination, which is added to the azimuth, west declination, which is subtracted from the azimuth. Okay. For magnetic survey instrument, we must use a non-magnetic drill collar. The survey instrument must be placed within the collars to minimize the magnetic interference, which is near the middle. Now we'll talk about the survey instruments, which is significant in advances in directional drilling technology. For the PDM, which is positive displacement motor, uses drilling fluid to rotate the drill bit without rotating the drill string. And from the advantages of the BDM, which is positive displacement motor, it provides high torque and power, works well in hard rock formation, and effective in slide drilling mode for steering. And for the disadvantages, which is limited life due to wear on rotor and stator, requires high drilling fluid pressure. For the bend sub, which is a fixed angle connection between the drill pipe and downhole motor to create curve. And from the advantages of it, which is simple or cost effective, requires no electronic component. And for the disadvantages of the bend sub, which is non-adjustable once installed and requires frequent slide drilling, slowing penetration rate, can cause high dogleg severity. And from the applications of the bend sub, which is used in kickoff point for wellbore deviation. For the wireline steering tool, which is a tool lowered on wireline to measure and adjust well trajectory, can be used within motors or rotary system. Geosteering real time for precise well placement and deep wells where measuring while drilling data transmission is weak. Also from the advantages of wireline steering tool, which is high real-time accuracy in wellbore positioning, can be deployed without stopping drilling, and from the disadvantages of requires wireline rig, which is increases complexity, can be slower than the measuring while drilling based steering system. For the measurement while drilling, which is MWD, which is provides real-time wellbore inclination, azimuth, and tool face by using downhole motor, directional and horizontal wells requiring continuous trajectory monitoring. And from the advantages of the MWD, or actually the measuring while drilling, real-time wellbore data while drilling and eliminates needs for frequent wireline survey. Disadvantages of the MWD, which is magnetic interference, can affect accuracy, requires mud pulse telemetry, which can be slow. For the steerable motor, which is a combination of bent housing and a downhole motor, allowing switching between rotary and sliding drilling mode, BHA, which is bottom hole assembly configuration, bent housing motor with an adjustable angles, used in directional control for high DLS sections, ideal of actually for kickoff, build-up, and lateral drilling. And from the advantages, which is more flexible than the fixed bend sub and can switch between rotary and slide mode. Disadvantages of the steerable motor, which is higher cost than the standard motor, limited azimuthal control compared to the RSS, which is rotary steerable system. For the RSS, which is rotary steerable system, which is an advanced drilling technology that enables continuous rotation to the, or actually of the drill string while steering the well bore in the desired direction. RSS allows for precise well trajectory control with an improved drilling efficiency. And also from the advantages of the RSS, or actually advanced of the rotary steerable system, high drilling speed, better wellbore quality, improved directional control, lower mechanical wear, and optimized data collection. And from the challenges of RSS, which is higher cost, which is actually expensive than the conventional drilling directional tools, complex downhole electronics, which is reliable telemetry for real-time steering, limited availability, which is not all rigs are equipped to handle RSS, which is to handle rotary steerable system technology. Actually, for the survey instrument for magnetic and gyroscoping. For magnetic, which is compass electronic, and gyroscoping, which is conventional return north-seeking ring laser inertial grid. And all of this we will make a discussion in it in the next session. For the electronic, we have the steering tool, which is tools makes replacing and fixing different part of vehicle steering system easy, safe, and less time consuming. For the MWD, or actually the measurement while drilling, which is a system of taking measurement while drilling downhole. And also for measurement while drilling, which is a real-time downhole surveying system that provides continuous wellbore trajectory data while drilling. It also optimizes the well placement, avoid collisions, and improve drilling efficiency. For the electronic multi-shot, which doesn't transmit survey data to the surface, but it stores the information downhole in a computer chip. So the main function of the EMS, which is to store information in a computer chip. So all electronic survey tool uses the same instrument to measure inclination and direction, and azimuth. So accelerometer used to measure the inclination, magnetometer used to measure the azimuth. Thank you.
Yeah, Dr. Nabil, are you done for today?
Yes.
Okay, so there are some questions in the chat box. Can you just go through them? Then those who have questions to ask, you can raise your hand and then we'll permit you to unmute and ask. Just check the chat box, you'll see them, then you can respond to them.
Actually, does RSS make use of mud or actually hydraulics to generate rotary motion? No. Rotary steerable system actually do not use hydraulics to generate rotary motion. Instead, RSS tools rely on mechanical or electronic steering mechanism while the entire drill string rotates. You're welcome.
Yeah, is there anyone who has a question? You can raise your hand, then we'll call you to respond to ask a question. Anyone from the students online?
Actually, when drill bit deviates more than planned due to the subsurface condition, for example, formation heterogeneity, differential sticking, or unexpected pressure zones, the deviation must be corrected to keep the well within the target zone. To identify the deviation, corrective actions for excessive deviations, for minor deviation correction or major deviation correction. And also what happens if the drill bit is bent? If the drill bit bends due to the excessive deviation, it must be pulled out and replaced because a bent bit will drill an uncontrolled erratic path. It can cause hole instability, excessive vibration, and tool damage. Running a new bit with a properly adjusted BHA, which is bottom hole assembly, ensures the smooth drilling. And preventing excessive deviation in horizontal wells, to use the real-time measuring while drilling and logging while drilling to optimize BHA design, plan trajectory within geological modeling to avoid weak formation, use high performance bits, which is polycrystalline dynamic, or actually polydiamond cutter bits with an improved stability help minimize deviation. That's it.
Is there any other question? Anyone having any question? You are free to raise your hand and you'll be called up to ask your question for those who have a
Yes.
question.
Actually, for the horizontal versus the vertical drilling, which gives higher yield, actually the yield, which is production rate of a well, depends on factors like reservoir properties, permeability, pressure, and fluid type. In most cases, horizontal drilling provide a higher yield than vertical drilling due to increased reservoir exposure.
So So I think that's a response to the person who asked the question if horizontal and vertical drilling,
Yes.
which gives high yield. Okay. Which one gives high yield? Okay. The next question is okay. Ajua Basdio is asking, is production done during the drilling process, after the drilling process? Production is done after drilling. So that one you should know it. Is when you finish drilling and you do completion, then you can go into
Yes,
production.
actually, oil and gas production starts after drilling and well completion, not during the drilling process.
So another person is asking, Lucky is asking, how can one determine the exact amount of slide to put while sliding the slide length? I don't know whether you get understand his question, Dr. Nabil.
Actually, determining the exact slide length and directional drilling. When using slide drilling, which is within mount motor bend sub to adjust well trajectory, it is critical to determine the right amount of slide length to achieve the desired well path correction. So the slide length depends on build-up rate, tool face control, and trajectory adjustments.
Yeah, Lucky, so your hand is up. You can unmute and ask your question if you prefer to ask directly rather than typing. You can unmute and ask your question. Lucky Nadozie. So yeah, for this other person who is asking, okay, can you please go deeper
Okay.
in Lucky, go ahead with your question.
All right. Yeah. Good evening, Dr. Nabil. Okay. The question I want to ask is the where you mentioned adding and subtracting the declination to the azimuth. So I want to understand that part very well. And
We
why
can
do we have? Can you hear me?
please come again, come back with your question. Your mic was breaking at an interval.
Okay. I said
Yeah, go
while
ahead. The trainer is hearing you. Yeah.
okay, yeah, during the training, the course of the training, doctor made mention of addition and subtraction to the azimuth, to the magnetic declination. Where he said when he's on the left side, we on the east we add, while on the west we subtract. So I'm saying if he can throw more light on that very part, and why do we have to add and why do we have to subtract? I didn't get that part very well.
Dr. Nabil, did you get his question?
Yes.
Okay, you can go ahead to answer him.
So actually, yes, in directional drilling, azimuth corrections are necessary due to magnetic declination. The angle between true north and magnetic north, whether we add or subtract azimuth, depends on whether declination is east or west. So why we add or subtract azimuth? To convert between magnetic north and true north. So we use east declination to subtract the declination and west declination to add the declination. So
Okay, that's to make correction to the angle.
to convert actually to convert between the magnetic north and the true north.
Oh, okay. Okay, I got it. Thank you, sir.
You're welcome.
Any other question? So I think this person is asking, can you please go, okay, uh, Baji is asking, can you please go deeper in that? How is it done if after drilling for the hydrocarbons? Is the pressure not too high then during drilling? Is that what they mean by formation pressure? So he's asking a lot of questions in terms of understanding. I don't know whether you get these questions, but I think from his questions, I will understand that he's somebody who definitely have very limited knowledge in the oil and gas industry. So I don't know, doctor, if you want to ask his question, answer his question. Then after that, we will listen to Lawal, Oladimeji Lawal ask his question. Doctor, can you hear me?
Yes.
Yeah. So his questions, I think he's just asking about the overview of the oil and gas industry, what takes place from production, from drilling to production. Yeah, I
Yes,
think that's
actually for drilling phase, which is during drilling, the focus is on creating the wellbore to reach the reservoir, installing casing and cementing to stabilize the well, running logging tools to evaluate the formation, and then com completion phase, which is perforation, well stimulation, installing production tubing, and also Christmas tree, which is surface equipment to control production. And then we go to the production phase, which is wells begins flowing naturally if pressure is sufficient, artificial lift, which is used if pressure is low, for electric submersible pump or gas lift or rod pump. Hydrocarbons are separated and proceed. Also, for the another question, which is in horizontal drilling, actually, how do we balance the soil stratigraphy? In horizontal drilling, maintaining balance within soil stratigraphy, which is rock layers, is crucial to prevent wellbore stability, excessive deviation, and differential sticking. So, from the challenges of soil stratigraphy in horizontal drilling, which is the formation variability, differential sticking, abrupt lithology changes, unwanted deflections, methods to balance stratigraphy in horizontal wells, which is for well planning and geological modeling, adjusting on drilling parameters like wet on bed revolution per minute or actually mud density and composition to maintain wellbore stability. And also we need to choose the right BHA, which is actually right bottom hole assembly and drilling technique. And also hole cleaning and wellbore stability to use the high performance drilling fluid to control formation pressure and prevent swelling. Optimize hole cleaning, adjust mud velocity and hole angle to remove cuttings efficiently. That's it.
yeah. So, doctor, another person in DK is asking a question. He's asking if what is the required pressure and temperature for both horizontal and vertical drilling for effective fluid flow? When you respond to that question, we'll allow Lawal ask his own question since we have enabled him to unmute. Yeah,
What
doctor,
is
did you
the
get the
Yes, yes,
question that?
yes.
Yeah.
What is the required of pressure and temperature for both horizontal and vertical drilling? The pressure and temperature requirement for drilling fluid depend on well depth, reservoir condition, drilling orientation. Proper fluid flow ensures hole cleaning, formation stability, and wellbore pressure control.
Okay. Lawal, you can unmute and ask your question now.
Okay. Good evening, everyone. Thank you, facilitator, and good evening, doctor. I just want to quickly ask that, given the advancements in the drilling technology from the 60s, I guess, to 2000, I just want to know. I'm a bit curious to know if there had been any review of late to see if what currently obtains to guarantee or enable maximum drilling capacity that will enhance production. Have been reviewed, off late, and then or is it that what we currently have is the best that we can get? Thank you very much.
I'm really sorry, I didn't get the question.
Yeah, so I think his question, what he's asking, is trying to inquire based on the how technology is advancing. Is the current training, the current technology we have now, is it more conventional in terms of the horizontal wells compared to the previously known wells? I think if I should summarize, I think that's what he's asking. So
So
maybe
the
before,
question is, the advanced in drilling technology, is the current technology, is it more conventional than what?
if it's more conventional than the previous methods of drilling. Am I right? Is that what you're trying to ask, Lawal? You can unmute and ask, you can unmute and confirm so that if we're responding
Okay,
to you.
that is very correct. And also, in addition, I was just curious to know if what currently obtains is the best technology for to get maximum production output. So that's practically or pretty much the question I asked. Thank you.
Yeah, so before Doctor respond to you, let me just say some few things as respect to your question. Then maybe Doctor will add more. Like, technology, the oil and gas industry has advanced greatly. Majority of the wells that are being drilled currently are mostly directional wells, so they are horizontal wells. And the advantage over, I think, when one of the leading companies, when I was with Halliburton, when I'm talking of a firm that I'm aware of, that I've been with them in the drilling department. A lot of issues, a lot of wells now that are drilled are directional wells. And the advantage of these directional wells is that it will allow you access a larger reservoir spectrum or a larger reservoir area that that previously those vertical wells will not enable you gain access to. So if I'm speaking to a layman, that means maybe depending on the size of your reservoir, your oil well or your gas well that you have seen, if you are focusing on a vertical well, then the level of coverage will be limited to comparing it to if you actually had an horizontal well. And for the aspect of directional drilling, directional drilling is the aspect is focusing you in the area whereby you have a precise well placement enable for you to be able to reach complex formations, because without directional drilling it will be difficult when you have complex formations, especially when there are barriers. So but with directional drilling you can bypass some of those barriers, and there are a lot of reasons why you can use them. And I don't know if doctor mentioned, but also for me to mention, considering that I'm also in the oil and gas industry field, one of the most conventional drilling technologies that are currently being carried out in the industry is the extended reach drilling, that's ERD. And it actually helps to drill wells at greater distance, because if you carry such a technology in a continent like Africa, whereby people always have a lot of challenges with communities accessing sites for drilling operations, then most companies, this is what they deploy. They can go, like, for instance, they can come, they can, it's, you can drill from a directional well from a very long distance. If maybe, for example, there is a war ongoing in that area, you can set your well from a very long distance, your directional, your ERDs, and you perform your drilling, and while war is ongoing, drilling operation is taking place. So you don't need to come at the site where those crises are taking place to set up your rig, which might be unsafe, both for personnel, equipment, and so many other stuffs that can be very critical. So those are the industry is advancing, and that is why you see, I think you have a short course like this, because by the time you understand, do short courses like this to showcase that you understand that the energy industry is changing, the oil and gas industry is changing or is deviating from its conventional ways, it has a way of representing you, because someone who gets some of these informations come to realize, because I know many individuals who don't go to the field. They just think, okay, it depends on whichever you prescribe, but it has gone beyond prescriptions, but it's far more on the importance or the necessities, the advantages, and what you stand to get. And another most convenient technology, we can talk of automated drilling systems in terms of what AI is also doing. And most of those things, those are conventional technologies that are currently taking place. And another key innovation too is the MPD, that's the managed pressure drilling, which doctor spoke about. Most of them, you're talking of your MWD, LWD, logging while drilling, or MWD. I know some of you didn't understood what he was talking about. MWD stands for measurement while drilling, because while you're drilling your MWD, they are giving you the informations of your well and the surrounding formations real time. So it's not like in the days of the past that you drill and then you have to pull out before you send in login tools to get some of those information. So while you're drilling, you're getting those informations that you need, and you can be able to know how far you're getting close, or how close to you are to your pay zone. So these are all advancement in the industry. That is why drilling, the level of precision is high. Every industry have their own specialized tool. Like in Halliburton, their main tool they use for directional drilling, they use GeoPilot. I think if you go to Schlumberger, I've forgotten the main tool they use, but I will think about that. So every industry is advancing. Why you have GeoPilots that does all the steerings, they still have their normal drill strings, whereby they will bring in the MWD attached to the MWD tool attached to it, then add, as well as they will add also the MWD. So it's a combination of tools that they will link up to the drill string, and then while you're drilling, you are getting all the informations you need, even IRS, including Batsonics. You have a lot of tools that you can add up. So why am I saying this? Just to give my own added information in terms of field knowledge, because the long gone are the days that you use just a drilling tool to be drilling. But the drilling tool itself comprises of so many other strings that are attached to it for several other purposes. So in your drill string, your one long drill string that is going down the hole to drill, you can have your MWD attached to it. You can have your LWD attached to it. You can, if you want to get yeah, but Sony, if you have other parameters depending on the prospects that are coming from either from your team, from the well planning team, whatever the information they need to come out. So all of those things are the conventional ways that are being changed, being upgraded, and it's a vast knowledge. So these trainings like this are good because it also help inform you what is actually going on in the industry currently, and it will also keep you at breast. You know, the oil and gas industry is not just for petroleum engineers. A driver can work, you as a driver without being a petroleum engineer, you can work in the oil and gas industry. As a nurse, you can work in the oil and gas industry. As a lawyer, you can work in the oil and gas industry. But to be effective in each of these fields, if you are going into this industry, you need to have some of this basic knowledge, because when they're saying some things like all these terminologies you see being used, you get a proper mastery and understanding. So Doc, I don't know whether you have something to say again to add to the question Lawa was asking, or what I
Well,
added
before
as well.
you actually go, facilitator, let me quickly just thank and appreciate your most elaborate submission, because you really
Yeah,
touched the core and most pivotal, part of the question I asked. Thank you, and God bless you.
you're welcome. But Doctor is more experienced than me. Oh, he's the
Yeah,
guy at the top. I'm
yeah,
just
I'll be
the
willing.
experience in
I'll
the
be
field.
really willing to listen to Doctor. Yeah, man. Yeah,
Yeah.
thank you. Yeah.
Yeah. So, Doc, you have anything to add up for us to learn from you?
No, actually, your answer is great. Thank you so
Okay.
much.
Okay. Thank you. So, Okay, we have Prince. Your hand is up. You can unmute and ask your question.
Okay, good evening, everybody.
Yeah, good evening.
Let me use this opportunity to appreciate Doc for tonight's lecture. And I'm a geologist. I just want to ask a simple question for clarity's sake. I know that directional drilling is typically limited to depths, but my question is on the environmental limitations of directional drilling, especially in groundwater protection, because I know that drilling can potentially contaminate groundwater aquifers, and there ought to be some required special precautions. So the question I'm asking is, what are the necessary precautions that needs to be taken in order to avert this contamination of our groundwaters when you're drilling? That's my question. Very sensitive. Is what are the precautions that should be taken? We need to put into consideration. Some of our students here, so we need to know. Please, Doc. Thank you.
Sorry, but please, can you see the question again?
Okay, I was asking a question is that I'm aware that from all you have said that directional drilling is typically can be limited to certain depths, but my area of concentration is on the environmental limitations, especially in groundwater protection, because when you're drilling, there is every potential that the groundwater can get contaminated. On this note, are there special precautions that should be taken in order to avoid contaminating the groundwater? If there are, please, can you just highlight some of those precautions that should be taken note, especially in the oil and gas industry, to avoid these effects?
Yeah, Doc, did you get his question?
You mean that in groundwater production, what are the methods taken in the directional drilling? Is that what you mean?
Yeah, I think he's talking about the safety factor of directional drilling. Does it have any effect on
I don't know if
the
I can
ground?
repeat the question again.
You can summarize the question.
The question I'm asking is, when you're involved in directional drilling, there are environmental limitations. And one of it that is of basic concern to me is groundwater protection, because there is every tendency that the groundwater can be contaminated. My question is, what are the necessary precautions that we should take note of to avoid contaminating groundwater while drilling?
Yeah, Doc, did you get his question?
What I got that in groundwater production, what is the contamination taken in directional drilling? Is that it? Is that it?
Yeah, I think that's one part of it. Or let me say in summer, he's like inquiring what are the limitations of directional drilling, if I should summarize what he's trying to know.
Actually, for the contamination risks in directional drilling from groundwater production, which involves risks of contamination. So the main concern arises from drilling fluid surface pollutant and actually cross-contamination between the aquifers. So actually, there's drilling fluid contamination for mud invasion or chemical additives. If non-biodegradable additives are used, they may pollute drinking water sources. And also, we have other things like surface contaminants, cross-contamination between aquifers. for saline water intrusions and contaminate migration, which is poor well-bore integrity, can let pollutants move between geological layers. So to prevent this contamination in directional groundwater drilling, which is you have to use the proper actually casing and sealing to prevent fluid migration and cross-contamination, to reduce mud losses into aquifer, to regular water testing, which is ensure no contamination from drilling operation, and avoid drilling near polluted zones to prevent industrial and agriculture runoff infiltration. That's it.
Yeah, thank you, Doc, for that amazing response. I hope you had his question, Prince. So, like he's saying, if you are a geologist, you should understand that you don't just drill. While you're drilling, like Doc mentioned, I'm just explaining what he has said because he's explaining the higher explanations. I'm trying to break it down. So what he's saying is when you drill, you have to do after drilling, while you're drilling, you have to run cement into the hole. You don't just drill, then you keep drilling. That is why you have to, the mud engineers will have to do their job to get you the best form of cement for you to use while drilling, so that you're not just drilling, you are drilling and cementing the well at the same time to prevent maybe your mud or your drilling fluid moving into process. There's no way you can contaminate your groundwater. And then another question, it's not like a question, but it's a statement you made that I also think is not actually true, because you say directional drilling is limited to depth. That is not true. Like I made mention of the ERGs, that's the extended reach drilling. You are talking of a drilling exercise that exceeds over 12 kilometers. We're talking of more than, if you convert kilometers to miles, because in the oil and gas industry they work more with miles and with feet. We're talking of over close. If you convert that to miles, it's almost close to 7.5 to 8 miles. So you cannot say it's limited to depth. That's what you might not achieve if it's in terms of vertical well. So I don't think that was a right statement. So probably you have to review that further. Since you are a student, it's important you know that. So any other question? Any other person having a question? Okay, doctor, someone is asking, can they get the material? So you are the owner of the material. It's your choice to decide.
We'll see this issue.
Dr. Nabil, can you hear me? Or can you hear the...
Yes, I can hear you.
Okay, so DK is asking, Doc, does it always mean that while drilling, you get gas followed by oil before getting water? Did you hear the question? Okay, someone
Actually,
is
which
asking,
is
Gloria, you're asking extended what? I don't know if you're asking based on what I talked about. I don't know if that is what you're asking. Maybe you can explain. Extended reach drilling, reach as REACH, or just, you can just Google ERD drilling or extended reach drilling. You will get to know more about that. So, doctor, can you get the question the person is asking? That's the case. Asking, does it always mean that while drilling you get gas followed by oil before getting water? And he continues to say, what of subsea drilling, where drilling is done underneath seabed? Dr.
actually does
Navi,
not
confirm if
always
you heard me
stop.
clearly.
Yeah, Does gas always come from before oil and water while drilling? No, gas doesn't always come before oil, and oil doesn't always come before water. The sequence of hydrocarbon encountered while drilling depends on the reservoir structure, pressure gradient, and fluid distribution within the formation.
Okay, thank you for that. So another question that okay. What are some of the mitigations that putting in place in order to, okay, you have answered that already.
Yes.
Okay. So, Doc, you didn't answer the questions. Can the students get access to the materials for the training for review?
As I said, 2/3 that I will see this issue.
Okay, okay, acknowledge. So another person is asking for controlling the well and to prevent a kick occurring, what is the required pressure? And how do you calculate how much hydrocarbons are there in the reservoir? And how can you decide how many barrels you can produce daily? So that's Arjuna Basdio's question. Do you want to answer it or I should respond to the person? Doctor, can you hear me? Dr. Nabe.
Yes, yes, I can hear you.
Okay, did you get the question?
Yes, actually.
Okay, so you can go ahead and answer.
Yes, actually, for controlling pressure when a cake occur when formation pressure exceeds the wellbore pressure, allowing flowing fluids, gas, oil, or water to enter the wellbore. To control a cake, we need to manage three types of pressures, types of pressure in well control, and actually controlling a cake by using well control methods like increase mud weight, use drillers or weight on weight method, blow up preventer activation to prevent uncontrolled flow, estimating hydrocarbon volume in reservoir. Actually, to determine the amount of hydrocarbon in a reservoir, we use the oil initially in place or gas initially in place. And for the calculations, which is actually by using the formula of original of oil initially in place and gas initially in place, also then to get the recoverable oil, which is oil initially in place multiplied by the recovery factor.
Yeah, thank you for that. Is the material necessary? So okay. So for the okay, I think all questions on the chat box has been answered. Is there any other person who has any other questions before we end today's class? Take note that for the now, the questions are in the course is in two folds, and today is just for directional drilling and horizontal drilling. And this is the introductory session of the course for directional drilling and horizontal drilling. The completion for the course will be done on Sunday, same times from 7 p.m. 1 hour class, and immediately after the Sunday class, the exam link, Doc will share the exam link in the chat box so that you guys can take the exam. Those who perform, those who are successful in the examination will be qualified to request to get the certificate of the program to show that you participated and successfully completed the directional and horizontal drilling course. Then those who are interested in the petroleum refining, the course will be coming up next weekend. That's Friday next week and Sunday. Then after then, Doc will be going to the field for work. So then once he come back from the field, we'll be rounding up the remaining for in an intense 1 week session. That means on a daily basis, it will be a rigorous back to back to complete them in the next 1 month. So when the time will come, further instructions will be given as we keep doing that. So on Sunday, we'll be meeting to complete the directional and horizontal drilling course. And then we will see how we can be able to make more meaningful sessions from all that we are having. Is there any other person who is having any other question for Doc? Any other question? Okay, someone say yeah. Okay, Engineer Suleiman, you can unmute and ask a question because we are about ending the class. So you can unmute and ask if you have a question to ask. Or you can type your question in the chat box. Yeah, Engineer Suleiman, you can go ahead with your question, please, and be brief. Can you go ahead with your question?
Yes. Yeah, that is my question. I just
Yes,
only want to ask, what other methods aside from water and gas injection to revive a well that is no longer producing?
actually, for this method, target reservoir stimulation, wellbore cleanup, artificial lift, and also advanced recovery technology.
Yeah. Can you come back, please? I can't hear you very clearly. You're breaking. Oh, have you seen the question there on the chat? Hello.
Yes, actually, for optimizing oil production from a non-producing well without water or gas injection, which is used to enhance production without relying on water or gas injection. These methods target reservoir stimulation, wellbore cleanup, artificial lift, and advanced recovery technology, which is like the wellbore cleanup and stimulation, artificial lift methods like ESP, road pumps, gas lift, mechanical and perforation enhancement, which is adding new perforations or deep penetrating charges, or removing damaged perforation, horizontal and side tracking and multilateral wells, thermal recovery for which is improved mobility and contains high viscosity oil, steam sock or downhole heating system, reservoir management and advanced logging, which is those methods are production logging tool, microbial, enhanced oil recovery. And that's it.
Yeah, thank you for that excellent question, excellent response. I don't know if any other person is having any last question. If not, then this is where we'll be calling it a day for today. Why we hope to meet again on Sunday. And then, okay, what is the major indicator for one to know oil deposit site before? Okay, is that the question you want to attend to, Doc? What is a major indicator for one to know oil deposit site? I think it's like asking to know how do you know that there is oil present in a field before you start drilling, or oil present in the reservoir before you start your drilling? Is it something you want to answer before we end the session?
Yes, actually,
Dr. Nabi,
for major indicators
confirm
for
if you can hear me.
actually for major indicators for identifying an oil deposit, which is for geological indicators, geophysical indicator like seismic survey, gravity and magnetic survey, aquatic logging, resistivity logging, geochemical indicators like surface oil swaps, oil seeps actually, and soil and water anomalous microbial activity. Well logging and drilling confirmation, which is for mud logging, wireline logging, drill steams testing, and also how to confirm an oil deposit to start with geological and supply data, use geophysical survey, drill in exploration well and analyze cuttings and logs, conduct flow testing to verify hydrocarbon production. That's it.
Okay, thank you, Doc. I don't think anyone is having a question again at this point in time. If anyone is having a question, please you can just drop it in the chat box. We'll collate them and then forward it to Doc so that he'll be able to respond to them. Then they can be forwarded back to you guys, and then we will see you guys all again on Sunday. So don't forget, same time on Sunday. You're free to go over the session if you wish to, and then don't forget to make your notes, and don't just limit yourself to the note in class. You can use your Google to do research. You can also use your chat GPTs and others to do further research to get more understanding. So good night to you all, and it was a nice day having you in class today. So bye. Good night. Good night, doctor.
Good night.
Good night. Thank you.
You're welcome.
Yeah, good night, Doc.
Good night, doctor.